Assalamualaikum and hi, we are from Group 7 and in this video, we will present about related rates. Our group members consist of Muhammad Syafiq Aiman bin Azlani, Muhammad Syakib bin Mayazid and Fidausyah bin Razali. So, without wasting times, let's move on to the next slide. First of all, we are extremely grateful because we were able to finish this video presentation within the time frame set by our lecturer, Dr. Siti Afika Muhammad. This assignment will be impossible to complete without the incredible collaboration and effort of our group members, Fidaus, Syakib and Syafiq. We also want to thank our Calculus 1 lecturer, Dr. Siti Afika Muhammad, for her guidance and willingness to assist us in areas where we are lacking when completing this assignment, as well as for teaching us this course. Conclusively, we would like to express our gratitude to our family members who have never stopped encouraging us. So, what is related rates? Related rates of change are simply an application of the chain rule. In related rate problems, you determine the rate at which a quantity changes by relating it to other quantities whose rates of change are known. Why do we use related rates? Related rates and related rate problems make use of quantities that are related to one another. Using the rate of change of the second quantity, we can determine how fast or slow a certain quantity is changing. For example, recently we have mentioned that we used balloon to calculate how fast or slow the air changing or increase. What is example of related rates? When two related quantities changes over time, the rates at which they change are related. For example, when a balloon filled with air, both the radius and volume of the balloon increase.
My name is Muhammad Syafiq Aiman bin Azlani. My ID is 2021 209 518. I will proceed to the next slide. A 15-foot ladder is pop up against a home wall. The ladder's base moves horizontally away the wall at a rate of 14 feet per second. As a result, the ladder's top moves down the wall when the base of the ladder is 9 feet from the wall. Based on the question given, the ladder was originally immobile, means the ladder was not moving at the first place. The bottom of the ladder moved forward at the rate of 4 feet per second. Then, the distance between the wall and the bottom of the ladder is 9 feet. The question is, at what rate the top of the ladder sliding down the wall? Based on the information, we are given house and a ladder. And we already know that the length of the ladder is 15 feet. You can imagine that the shape between the house and the staircase has a triangular shape. Basically, the hypotenuse of the triangle is 15 and 9 for the adjacent. Also, we are given 4 feet per second as a dx over dt. What the dy over dt when x is 9 feet? To complete the sub-problem, we have to use Pythagoras theorem, which is a square plus b square equal to c square. We substitute the a with 9 and the c with 15, and the 9 square equal to 81 and 15 square equal to 255. Next, 81 move to the right in order to get the y value and subtract with 225 and get 144. After that, the square above y move to right and the opposite of square becomes the square root. Finish it and the answer of y is 12. Using the chain rule formula, we apply the chain rule inside the Pythagoras formula, which is we differentiate layer by layer. The first step is we plus the d over dt for every variable. What is the d over dt? The d over dt indicate to differentiate symbol. The second step, we differentiate one by one. X square equal to 2x dx over dt and y square to 2y dy over dt. 15 square equal to 0. As a result, we simplify the 2x and 2y and get x and y.
Hello, my name is Fidausha bin Razali. My ID is 2021201788. So we continue with the next step. For the last step, we know that we are given dx over dt equal to 4 feet per second, and we want to find dy over dt at the instant when x equal to 9 feet. So, from the last equation, we get x dx over dt plus y dy over dt equal to 0 by using the chain rule. Then, we can find the value for dy over dt by substituting in the various values. We have at the moment that x equal to 9 and y equal to 12. So, we can make those substitutions, and we were given that ds over dt is 4 feet per second. So, now we just left with multiplication. Negative 9 over 12 times 4 feet per second. Then, we get the answer is negative 3 feet per second. So, we jump to conclusion. In conclusion, the bottom of the ladder ds over dt falls positive for 4 feet per second as it falls forward, and we apply Pythagoras theorem to find the length of the opposite and then solve it using the chain rule method. The top of the ladder dy over dt going down logically becomes negative. As a result, the top of the ladder sliding down the wall at the rate of negative 3 per second.